problem. So here is the question, and here are the parts of the question where we have to find out the value of A and J, and if E is equals to 4, what is the value of D, right? Alright, the very first thing which you have to remember while solving questions on cryptarithmetic problems is that all the alphabets will have unique values, right? Now, let's solve it with a very traditional way of multiplication. B, when multiplies JE, is giving result as JE, right? What will be the value of B in that case? Obviously, B has to be equal to 1, right? So, I'll replace all the B's with 1. Okay, we are done with this part. Now, let's move on. When 1 multiplies JE, it gives JEA. A actually doesn't make any sense. The only value which A can have is 0. You can check the same by adding these both. E plus A is giving me E, which essentially means that A has to be equal to 0, right? So we have found B and A value. Now let's move on to finding out any other possible any other possible alphabet whose value we can find. So, alright, also let's replace A with zeros. Now, look carefully. There would have been some carry which gets added to J and gives 10 as the answer. What can be the possible value of J? It obviously has to be 9, right? In that case only, 9 when gets added to some carry, and this carry also can be at max what? 1, right? So it gives the carry plus J is giving me 10. So J value has to be 9. So we have found out B value is 1, A value is 0, and for J the value is 9. We are done with the first part of the question. Let's talk about the second part of the question, which obviously is getting easier and easier now. Replacing J with 9. Nine plus E gives me D. If you remember, I told you that any digit n when added to 9 gives n minus 1 plus carry as 1, right? Alright, now 9 plus E. Here we are telling that E is equal to 4. If E is equal to 4, 9 plus 4 will give you 3, and the carry goes on here. So that's it, right? If E value is 4, then D value will be 3. So finally, if E is equals to 4, then the value of D is 3. Simple question, right? Let's move on to the next question now. So here is our next question. As we have already seen that there are some certain rules which we have to follow while solving questions on cryptarithmetic problems. So the same rules we are going to follow in this as well. You can see sen plus more gives money as the result, right? And this is an addition operation which we are performing on these alphabets. Now these alphabets will have their unique values ranging from 0 to 9, right? Alright, now let's start it. If you remember, we already spoke about one rule, which is if there are n digits in a number and another number is there which have n digits again, if you add these and if you are getting a result which has n plus 1 number of digits, then the leftmost digits happens to be 1, right? So similarly, here we are having two numbers which are having 4 digits each, but the result is having 5 digits, which essentially means that the leftmost digit is going to be 1, right? So I hope this is very clear. So I'll substitute m with 1. Yeah, alright. So now we have m as the value 1, right? Now we have to find out the other values as well. Now this alphabet which looks like theta is actually O. It's just that I wanted you to be clear on where I'm writing 0 and where am I writing O. So theta is nothing but O. Alright. Now we have to find out what is the value of O. Okay, so pay attention to this. This might be a little bit complicated. See, there are 4 digits in this, right? What can be the maximum value? It can be 4 consecutive 9s, right? And given the fact that we already know the value of m is 1, I'll put this as 1. And rest of the digits, I'm again putting the maximum possibility, which is 999, right? So we have these as the maximum possible numbers which can be there in this, right? All right. Now when we solve this, when we add this up, we are going to get what? Yeah, 11998 as the sum. Now I can say one thing about O, that is it will be either 0 or 1, not more than that, right? This is the maximum. This is what we are doing, right? We are just finding out the maximum possible value of O. So maximum possible value can be 1. Also, we already know that m has already taken the value of 1. So O cannot be 1. Definitely it has to be 0. So O takes the value of 0. Substituting the same in the problem. Yeah, so we get this as the result. I hope we are clear till now. Alright, moving on to the other alphabets values. So here we have S plus 1, which gives me 10. What are the possible values of S? See, either it will be S plus 1 gives 10, or it will be S plus 1 plus a carry, which is again 1, right? So from here I can get S value as 9, and from here I can get S value as 8. So S can be either 9 or 8. Remember this, alright? As of now, we can't go, we can't find the value of S exactly. So we'll try to see if there is any other thing from which we can move on to this particular value. Finding out the value of S. Okay. Now, I have another row which says E plus 0 is equals to N. Now tell me something, if we add anything to 0, what shall be the result? Obviously the same number, right? So, but over here what I'm getting is different thing. I'm not getting E plus 0 as E. I'm getting it as N. Definitely, there has to be something which is getting added to E, which gives the result as N. So, we have seen already in the previous set of rules which we have discussed that any carry in such a, any cryptarithmetic problem cannot be more than 1. So, it can be a maximum carry of 1. So, I'm considering the same. So, it is like E plus 1 plus 0 is equal to N, or I can say N is E plus 1. This is quite a very important equation which we have to remember for the further for the further solution. Alright. Now let's talk about the range which E and N can follow in. Okay. See, E can have any value ranging from 2 to 9. All these are possible values, right? So, E can have any value from 2 to 9. Because 0 and 1 are already taken by O and M. Alright. What can be the possible value of N then? N is 1 greater than E, right? So, if E is taking a value of 2, N can take a value of 3. Now, N cannot take a value of 10, right? So, obviously, it can take a maximum value of 9, which essentially implies that E can never be 9. It has to be 8. This is the final range which we are getting. Now, given this thing as well, we know that N is not going to be anything greater than 9. So, if it is not greater than 9, it's not going to give any carry over to the next row. So, from C3 to C4, no carry is going to happen. If there is no carry, it means that S has to be 9, right? In that case only, you will actually get S plus 1 as 10. Alright, so we now have a value of S as well. Okay, now that we have found the value of S, let's substitute the same in the question as well. Alright, now we'll try to find out if there is a carry from column 1 to column 2 as well. Let's see what are the possibilities for this particular row. It can be n plus r is equals to e plus 10. Now what is this? Let's understand this. If we are having two numbers 8 plus 7 which gives 15, I can write the same thing as 8 plus 7 gives 10 plus 5, right? So the representation is just about the representation of the numbers. So I'm just writing it as n plus r equals to e plus 10. So there is one possible case wherein we are not having a carry, which means that n plus r will give me e plus 10, given the fact that there is a carry from C2 to C3. Alright, so definitely 10 exists. Now, another possibility can be that there is a carry. In that case, I'll have n plus r plus carry 1. This 1 is of the carry, and e plus 10. Now, I have value of n. I have an equation saying that n is equals to e plus 1, right? So I'll just substitute e plus 1, I'll substitute n with e plus 1. So it will become as e plus 1 plus r is equals to e plus 10. Now, if we solve this, I'll get r as 9. But obviously, I just told you that there are two possibilities. So we'll also check the second possibility, which says n plus r plus 1 equals to e plus 10. Again, substituting the value of n as e plus 1. I have this equation, which essentially gives me r is equals to 8. So we have found the value of r as 8, and this we found by the equation, by the second equation, which says that there is a carry, right? So there exists a carry from column 1 to column 2. So now that we have established that there is a carry which is happening between C1 to C2, let's use the same fact and solve the question further. Also, let's replace this r by 8. Yeah. Now, we have this carry is happening from C1 to C2, right? What will be the equation over here? D plus E is giving Y. Because there is a carry from C1 to C2, it essentially means that whatever Y is, the total sum which we'll get out of D and E will be greater than 10. Then only there is a carry happening, right? So, let's try to solve this. So, we have D plus E is equals to, D plus E equal to Y plus 10. Alright, now if D and E give a sum of Y plus 10, what can be the possible values of Y? So let's try to find out what is the value of Y. We have already seen that the sum of D and E has to be greater than 10, right? So Y can take any value ranging from 2 to 7, but then Y can't take 0 and 1 because O and M have already taken the values 0 and 1. So the minimum sum which you can get out of D and E will be 12, and the maximum sum which you can get is 13. Alright, now let's substitute values of E one by one, considering all these numbers, all the possible values which E can take. Substituting the value of E as 2, D will have to take the value as 10. Alright, now in that case, obviously this is not a possible case because D or any alphabet for that matter in cryptarithmetic problems can never be more than 9. So this is not going to happen. So our assumption that E can be 2 is wrong. Taking the next assumption as E's value as 3, D will have to take a value of 9. Again, we know that the value 9 has been already taken by S. So this as well cannot be a possibility. If E takes the value of 4, this will have to take 8 as a value. That is, D will have to be 8. Again, we know that 8 as well has been taken by R. So this again is not a possible case. So taking E as 5, D can take the value of 7. Alright, so 7 plus 5, we will get 12, which essentially means that Y value will be 2. Now there is another case as well, which is 6. Let's consider that as well for time being. If we take the value of E as 6, D will have to be 7, right? But that is again not possible because N value is just 1 more than E. So if E is 6, N will have to be 7, which essentially means that D cannot take the value of 7. So E equals to 6 is again not a possibility. It contradicts the fact that E and N are consecutive numbers. Now, going back to our result wherein we found that 5 actually holds good. E, if it is taking value of 5, D will take the value as 7, which gives the sum as 12. So Y value will be 2. So Y is 2. E will replace with 5. D will replace with 7. And we know that E and N are consecutive numbers where N is 1 digit more than E. So this will become 6. Yeah, so this is the final answer with all the variables having their respective values as this. Alright, now here is our next question. We have been given that T value is 0. We have to find TEE plus TEE, what will be the final sum. Alright, let's substitute first of all the T's with 0. Look at this row. We have A plus A plus A. That is 3A. What can be the maximum possible sum? If A takes a value of 9, the maximum sum can be 27. Right? So, I can write the same thing as 3A equals E plus 20. This means E can take maximum value of 7 or it will be lesser than that. So, E can be less than equal to 7. Alright. Now, if this is the case, let's take all the possible values of E and check what holds good. If E is equals to 7, in this case, we'll get E plus E, that is 7 plus 7 plus 7, which is 21. And we know that there is already a carry of 2, alright, from this column to this column. So there is a carry of 2 and the sum of these three variables, these three alphabets will be 21, which means the sum of this whole column will be how much? 23. Now, if the sum is 23, we know that the total sum has to be BE, which means we are saying BE is equals to 23, wherein E has the value of 3. But just now we have taken the assumption that E is equal to 7. So it doesn't hold good, right? Consider the next value. So E is not equal to 7. Let's consider the next smaller value. E is 6. Considering E to be 6, it will be 6 3s are 18 plus 2, which is 20. Again, we are saying BE is equals 20. In this case, again, E represents 0, but we have taken assumption as E is 6. So again, this also doesn't hold good. Similarly, when you check for 5 also, you won't get the correct results. Consider E equals to 4. If E is equal to 4, in that case, what will be the scenario? This will be 4 plus 4 plus 4, that is 12. 12 plus 2, that is 14. So in this case, we are getting BE as 14, which means we are getting E value as 4. So this is correct. This holds good, right? So E value is 4. If E value is 4, we want 3A to be 24, which essentially means A value will be 8. Alright, so we have already found E value is 4, A value is 8. Now we have to find out what will be the value of these. So substituting E with 4 and T with 0 will have 0, 4, 4, 0, 4, 4 and the sum will be 0, 8, 8. So this is the final answer. With this, I hope we have done our bit. Now it's your turn to practice more and more questions on cryptarithmetic problems. Also, here is a challenge question, which is if a cube plus b cube plus c cube is abc, we have to find out the value of a, b and c. Please post the solution in the comment section and we'll be back in the next week with more questions on cryptarithmetic problems. Till then, keep at it.